Hi class, part 4 of inventory models, and I'm sure it's the last one. We were looking at this model where we have a multi-period with probabilistic normal demand, where the demand is it is not known with certainty, and that is why our inventory goes down in a not in a regular pattern, but it goes in an irregular pattern, as you can see. Because of that, because it's not perfectly predictable, we are going to have backorder periods, stockouts. Sometimes they're going to be big, sometimes they're going to be small, sometimes they may none at all. Okay. Unfortunately, the correct model for this situation is very, very complex. It's beyond scope. We're not going to see the actual model. We're not going to see the best model for this situation, but we're going to use an approximation that is very, very good. And to do that, we're going to share bits and pieces from other models. We're going to start with the how much to order question, the EOQ Q star. We're going to use the basic formula from the very first model, which is the square root of 2 times demand times the cost of ordering divided by the cost of holding. When it comes to when to order, right, that's going to give us the how much and when to order. That's going to be a little more difficult because we are going to need, because we know that we're going to have stockouts, back orders. So we need some help. We need to ask our leaders what is acceptable to them in terms of stockouts. How many stockouts are they willing are they willing to tolerate? And that information, we're going to use that information. Once we have that information, we are going to use the formula R equals mean plus Z times the standard deviation, which you've seen before, and you're going to see it again. That's going to give us an idea of when to order our Q star to make sure that we stay within that reasonable, tolerable amount of stockouts per year. Once we have all of that, we can actually calculate the safety stock. The safety stock is, that stock that you would have between the time that you put an order and the time that you receive the order, because of course you're still selling, between the time that you order and the time that you receive new inventory, and that's going to be equal to the ordering point, the amount that you have, in hand, and the amount of time, the amount of inventory that you're going to use during that period, during that lead time. That's going to give you the safety stock. Let's take a look at this situation with a problem. This firm estimates annual demand of around 8,008 units. The demand is expected to be normally distributed. Ordering cost is $12 a unit, and holding cost, your CH, is $120 per unit. Lead time is 1 week with an average demand of 154 units. So that's okay. The lead time is 1 week with an average demand of 154 units. Okay, and management is comfortable with 5% stockout. So throughout the year, they're going to tolerate a 5% chance of stockouts. So calculate the Q, calculate the reorder point. Your EOQ is remember, it's a basic formula. It's 400 units. 5% stockout represents, this is how you do it, represents 95% of the inventory is in during the year, right? And 95% has a value of has a Z value of 1.645. Right? You look at the tables, or you use the formulas that I've been giving you to calculate that. So that's your Z, 1.645. That is related to a 5% stockout probability, which is 95%. It's the opposite of 95%, right? So 95% of the time you are going to have inventory, 5% you're not. So in this case, I'm doing it that way. You can use it depending how comfortable you are with Z values. You know what to do. So the ordering point is going to be the mean plus the z plus the standard deviation, so it's 154 plus 1.645 times 25, which is my standard deviation right there. Is my standard deviation 25? Oh, somehow I missed it on the problem. It was not on the problem. The standard deviation is 25. I'll have to add it. So it's 195 units. That's your ordering point. So when your inventory reaches 195, that's when you put the order for 400 units. Let's see what happens during the lead time. The lead time is 1 week. Okay, good. So during 1 week, you're going to need 100. We know that because, the 1 week average demand is 154. So we know in 1 week, you need 154 units. And the lead time is 1 week. It happens to be 1 week. Otherwise, you will have to calculate, you will have to do the math. So if you order at 195, that means that for the week after, while you're waiting for the new inventory, you're going to use 154 units. That means 41 units is your safety stock. That's the stock that will, on average, keep you at 95% of the time. It will keep you from having a back order. In other words, if you keep 41 units in inventory, you're only going to have a back order 5% of the time. Now the next model and last model is the periodic review model with probabilistic distribution. We have made one assumption for all the previous models, is that assumption is that you always know your inventory. You have some computerized system, or you can just look at it, whatever it is, you always know exactly how much you have. In a periodic review model, you don't know how much you have until you count it. You actually have to do an inventory to find out how much you have. So, very common in some retail environments where they actually have to do like dollar stores and, some other retail stores. They actually have to do inventory to figure out exactly how much they have, so they can figure out how much they need. So that's the big difference. Here I have this sentence here. A simple analogy would be the gauge in your car that tells you how much fuel there is, right? It tells you all the time how much fuel there is. Thank God we have that, because otherwise you will have to always do the math of how much fuel there is left. And that has happened to me, because back in the old days, I was in situations where the gauge was not working. So I was always, I had to always figure out, right, I will fill up the tank, so now I know how much fuel there is. Then I will drive for so long, so I would have an estimate of how much fuel I have spent, and then I will add some safety stock, right? I will add a few liters, gallons, just to make sure that I didn't actually run out of fuel. So like I said, in a periodic review system, there's actually a manual count of the inventory. And this takes time. This doesn't happen overnight, right? It might take days or weeks, depends on the size of the establishment. So it takes time. Once you run that periodic review and you know exactly how much you have, then you're going to order a Q star that will hopefully bring it up to your desirable level, the level what we call replenishment, the max inventory that you like to carry. So for example, in a dollar store, again, if you like to carry 100 bottles of bleach, that will be your replenishment level, what we call M, letter M. And after you do your inventory, you will order enough Q star to get you back up to that replenishment level, the maximum inventory, if you will. Therefore, the amount that you're going to order Q star is going to be the maximum level minus whatever it is that you think you have left in your inventory, right? It makes sense. If your maximum level is 100, that's how many bottles of bleach you would like to have, 100, and you count 10, you have 10 at hand, then to replenish the shelves, that means that you need to order 90, right? 100 minus 10, 90. That's all it's saying. Now, this replenishment level, unfortunately, because things are going to be moving around, is going to be determined by the demand. And the demand is going to be, is not deterministic, it's probabilistic, and it's normally distributed. So to figure out approximately what that demand is going to be and that replenishment level, we're going to use the same formula again that we've used before, which is in this case, instead of calling it the reorder point, we call it M equals mean plus Z times the standard deviation, where the mean is going to be the average demand between inventory replenishes. We're going to see that in just 1 second. So basically from Q star to Q star, from order to order. This is a periodic review, so you're gonna be constantly periodically reviewing your inventory. Let's take a look. How does this look? Looks kind of like this, so it's very similar to the one before, right? It's like this. But here you have this review period. This is the time that you're counting your inventory. You're counting. It takes time. It takes a lot of time. And then at the end of the review period, let's say right here, you put the order in. That takes time. That's the lead time. And then the order comes in, your Q star comes in, and your inventory shoots up to some level. But of course, it doesn't hit. It actually doesn't hit the replenishment, the full replenishment level. Why? Because during the lead time, you have been selling this inventory. So of course, it's never going to reach that level. That's where you're aiming for, but it's not going to hit it because you are consuming some of it while you're waiting for the new inventory. Notice the moment a review period ends, another one starts. And sometimes you're going to have stock out periods. It's possible. And then other times you're not. This could be low demand, right? So I don't know when it would be a low demand for a dollar store, but this could happen. Now, because you just conducted a review period, you know your inventory is up here, is high. So your Q star is going to be small. It's not going to be the same Q star every single period because you have review periods where you are counting how much stuff you have left. And it is only after you complete the review period that you place the order. Let's look at an example. Let's say that every 3 weeks, the dollar department store places an order to replenish their stock. So every 3 weeks, so the review period is 3 weeks. And at the end of the period, they place the order. Weekly demand for Ace brushes, $1, approximately follow a normal distribution with a mean of 60 brushes and a standard deviation of 9 brushes. So that's your mean and that's your standard deviation. The lead time until dollar receives the brushes is 1 week. It takes 1 week to get your inventory once you place the order. So think about this, right? Your review period is 3 weeks, and then at the end of the 3 weeks, you put the order in for another week. So from review period to review period, This is what I'm trying to count. The length of the review periods are 3 weeks each, but the order that you place in one review period runs a week into the next review period. All right, so you will receive, while you're counting in the next review period, you're going to receive the new inventory that is going to shoot up here. Okay. If dollar has 75 brushes in stock, so you do your review period and you're counting 75, how many should they order if the lead time is 1 week? All right. So the first thing that you're going to compute is lead time plus review period. That's how long it's going to take from the beginning of the review. Let me go there. From the review period until you receive the next batch, which is here. So it's this plus that. So it's 3 weeks plus 1 week, 4 weeks. The average demand per week, it's Okay, it's 60. We have that 60. Okay, we have that weekly demand is 60. Yep. So for those 4 weeks, if we have 60 brushes demanded per week, and we have 4 weeks during that period, that means 240 brushes are going to be sold during this lead time plus review period. 240. Okay. Now let's calculate the replenishment level. Your M is going to be the mean plus the Z times the standard deviation. For a 2 stock, we're assuming another 2, we have it here, right? At most a 2% chance of running out of stock. So if you're looking at the 2% tail area, again, is a 98%, right? 2% stock out means 98% stock in. You're going to find that the Z is equal to 2.05. Therefore, M is going to be the mean plus the Z times the standard deviation of 9, which is going to be 558.45 brushes. Okay, if at the end of the review period, if they have 75 brushes in stock and the replenishment level is 558, that means that 258.45 minus 75, 183.45 is the amount of brushes that you need to order to get back to the replenishment level that you just calculated of 558. All right? Now let's see how that looks on Excel. Oh, I forgot to show you the Excel. I have an Excel for the previous problem. We can review it very quickly. It was this problem, yeah? Yeah, okay. 400 units, lead time 41, 41, yes. So as you can see, your economic order quantity is 400.20. All the formulas are there. You just have to enter the right values in the Excel. And for the periodic, which is the one that we're looking at now, that one. So we had the 3 weeks plus the 1 week. Average demand was 60. Okay. So the mean was 240. The standard deviation was 9. A 2% probability of a stock out. That's what we enter, at 2%. And 75 units left at the end of the review period. So the replenishment level is going to be 258. You see the formula there. Your safety stock is going to be there, and the EOD Q star, the amount that you need to order is 183.48, as we see here. 45. Interesting. I have. I did this by hand, and this one is by this one is Excel, and I did the other one by hand. There's a little bit different. There's a difference of 0.02. And that's it. That ends the inventory models. Thank you.